welcome to real-time updates with Websockets and Server-Sent Events, hosted by Seattle JS Hackers. Yeah. Intro. Wow, my internet's slow. So a little bit about me. My name is John Bergonia. I am one of the co-organizers for Seattle JS Hackers. I get really excited about people sharing new tech or old tech in new ways. I know that last week or a couple of weeks ago, we did a talk on introducing React hooks. That was really good. Next week, we'll be doing a talk on visually building React user interfaces, which is going to be interesting. Yeah. I currently work for a company called WebMocha. WebMocha is based out in the Bay. We have an office here in Seattle that we don't use because of COVID, so everyone's working from home. We build software for small businesses, startups, and enterprise. Yeah. So why am I doing a talk on WebSockets and server-sent events? Basically, I think that WebSockets are super powerful. I have a lot of fun using it for real-time updates or near real-time updates. I built video games, multiplayer video games with them. And obviously, they're useful for other real-time applications like chat, Slack, Zoom, many things that have bidirectional near real-time communication. So yeah, basically, it's fun. So back in 2016, we did a hackathon called Node Knockout, and we built this game called Dragons versus Unicorns. You know what? Let's play. I think I'll share my screen, and if anyone wants to play with me, say something. So all you have to do is go to this URL. I'll post to the chat. I just need one. Well, more people can play, though it's 1v1. So I'm going to create the game, MOQ. So if anyone goes to this URL and types in MOQ and then joins, then we can play. And whoever's playing, you can unmute your mic so we can talk. And then, yeah, so you readied up. I'm going to ready up. And here we go. So I think I'm on the bottom. And I'm going to choose which to attack. Oh, hey, Donnie, don't look at my screen. So I'm going to use this attack. I'm not going to say it out loud. So I'll choose this. And I'm waiting for opponent to choose. Oh, you're not playing. Who's playing? Whoever.
I think I might be playing.
Going to my game. We might.
I'm in a game, I believe.
Uh-huh. There we go. All right. So I think
yep.
All right. So you chose the rock and I chose paper and I won. So let's play again. So I'm going to choose a different thing. And you could choose rock, paper, or scissors. And I won't know your choice until we both choose.
Gotcha.
And cool. So if you see the green bar at the top, you're almost dead and I have full health. So I'm going to choose again. And let's see where this goes. Yeah, so if you chose rock and you win, you self-heal. Oh, wow, you did attack and healed up. That's pretty good. So this game was implemented using WebSockets. And yeah, we'll come back to this maybe. Or you know what? Let's do it now. Let's look at I don't think I'm going to come back to this again. So what I'm going to do is I'm going to refresh the game, which will probably log you off, and I'm going to create a new game. So if I create game, right when I hit create game, I'm doing debugging, and I'm going a little bit ahead here, though I don't want to come back to this demo. So I'm going to start debugging here. So RRQ, if anyone wants to join RRQ.
Somebody else want to jump in and play since I just got to?
So the one person who's going to join me, go ahead and do that. Everyone else, if you're watching my screen, what I did was I went to my network debug or developer panel. I filtered for WS, which is WebSockets, and I click on WebSockets, and then here I can see the messages. And I want to talk about these messages if we have time at the end of the presentation. Green means I sent it to the server, so I sent create. The server gave me a random code that and also a room, and then here it says opponent joined. So it pushed the message to me, it says opponent joined. When I click ready, I'll send ready player 1, and then I also get back the same response, ready player 1. I'm waiting for ready player 2. So can you press ready player 2? Oh, hello? It's possible that you may have gotten disconnected. It should have errored me out if you're disconnected. Yeah, there you go. All right, so I'm gonna create a new game. Somebody play me ZRG. And what's just interesting is you'll see that a quit message has arrived from the server, prompting my UI to go back to the beginning. All right, great. So opponent joined, ready player 2. If I click ready, it'll be ready player 1, and then we do game start. So again, these white ones come from the server, and then we get some information from the server for what are the possible options to choose. I'm going to choose an aggressive action. Oh, we both did that. I'll choose another one, not the same one. I'm going to choose something totally different. Okay, I did it. I chose the same one. So what we're looking at here is a stream of messages going back and forth between me and the server. The other player is getting different messages. So I did find what I do know when the player chose, so that when I click, the server will tell us both to resolve the game. And then here's the resolve. And then the pattern I'm going to talk about later is this op and payload, which has been really useful for me. So I'm going to stop playing. And you can play with anyone else, especially if you have kids, might be fun. It works on mobile, I think. Cool. So there's that, Dragons versus Unicorns. I recently made a hacking simulation I called the Gauntlet. And so me and a few friends, we're playing a cyberpunk role-playing game. It's like D&D for the future. It's called Shadow of the Beanstalk. And part of the adventure, I'm the game master, and part of the adventure, they have to, the players had to hack into a megacorp's network to steal some data. So I built the simulation for that one instance of this of the game. So it's like a prop for the role playing. Where since we're role playing on Zoom anyway, it kind of is fitting that everyone did this. And so I'm going to show a little bit of the experience. The goal was, again, that every player is able to hack into the megacorp's network, right? And so WebSockets makes sense for this, and it'd be really hard to do without WebSockets. So I'm going to show a quick video of them playing. Can you hear audio?
Not be able to hack proxy in time.
Oh, maybe not.
I have not been able to get this backup server.
Okay.
I got the
X mark
extra.
B on
Wait,
proxy.
what does that mean when it's
Extra
orange?
on intranet. Okay, I
don't
did
know what it-
oranges. So far, I've been doing oranges on these oranges.
I'm going to hit router with teal. Continuing. Starting from the top again.
Okay, I'm starting with the
What?
blue.
I don't remember what it's holding, and I
Does
don't
someone
know
want to
what,
go after
what does
web server
orange
as well?
mean?
Let's get
Isn't it
hackers on web
oh.
I
server.
can do that.
The res are
Accessible?
owned. Yeah, those are owned. You can.
But we gotta own router. We gotta own the router first.
I don't understand.
Oh, gotcha. Yeah, working on that.
Why?
Kelly, what are you working on?
I am not
Okay,
sure.
I got.
I don't
Okay,
know
Kelly,
what to do.
take
Yep.
the blue. Take the
Mhm.
blue row starting from the left-hand side and try
Okay.
to put it over router. Router is the second one up on the third column.
Third column, second one up.
Yeah, you see that? It says router.
I don't see anything that says router. Oh,
Yeah,
okay.
I
I see. Okay,
Okay,
third column.
Yeah, go, try to hit it with blue.
Yeah, I
Blue.
know.
Oh, okay. All right.
firewall be?
Getting this backup server. I've hit it with everything.
I'm getting the firewall be.
We're at 395. We're making good time. We're a little bit behind point, but we'll be okay.
So are we basically just trying to go through the orange ones and then?
Yeah. So hit all
data.
hit all the orange ones, but like what we're trying to do is oh shit, my firewall's been disabled. Go go go! All right, I own it. I own router with Mega ML.
Oh, Levin did the web server also.
Levin did the web server?
Yeah. Oh, Levin did the admin pro too. Levin's my best one.
Kelly, off control blue.
I'm just gonna apply
the one right above what you were hitting.
Killed that firewall. I'm so
okay,
happy.
I owned it. I owned it. Lambda. Lambda on off control.
By the way, none of the firewalls work, so you can just keep moving. Just go.
Yeah.
Is there a color I'm supposed to be?
Hey.
Cool. So yeah, that was really fun. So the team had 10 minutes to hack into the server, and I think that was really fun. So there's a lot of things you could do with WebSockets. Moving on, server-sent events. Another reason why I wanted to do this talk is because I haven't seen many people use server-sent events, and I'm not sure how many people actually know about it. Can you raise your hand or say something if you've ever heard of or used server-sent events? Cool. Yeah. So actually,
I've heard about it. Yeah. Always wanted to use it.
I think Manny introduced me to it when we had a project, and we were, debating on if we should use real-time updates, polling, or WebSockets or whatever. And since then, I found the power of it and the simplicity of it. And if ever it fits in my day-to-day job to use it, I definitely would. Yeah, so that's kind of why I want to introduce it here, because I think a lot of people know what WebSockets are. It's used all over the place. So, well, what are they? I guess I'll talk about that. Server-sent events. So WebSockets is bidirectional near real-time communication. Server-sent events is an API for getting one direction, single directional updates from the server. So server, you connect to the server and the server will push updates to you. And that could be useful if all you want to do is get the latest, greatest update in near real time. And you don't need the client to send the server back any information. Even if the client does want to send information back, there's many ways to do it. And still, I think that it could be more simple than WebSockets. So we're actually going to explore that in this talk. Cool. Oh yeah, and so WebSocket frame data format. The messages sent between server and clients in WebSockets could be anything. It could be any format. It doesn't have to be JSON. It could be pretty much anything. It doesn't matter, which is good. It's a good thing. And when I'm building certain applications or games, I found this pattern to be really useful, and I keep using it, and it's never failed. I've used it in enterprise projects as well, and it holds up pretty well. So I want to share that with you in case you didn't, in case you wanted to use WebSockets and wanted a nice way to organize your messages. It's basically the op payload thing that that we went through with the Dragons versus Unicorns game. Cool. All right. So let's talk about WebSockets. Before we do that, let's talk about basic HTTP for contrast. HTTP. All right. So here's the basic protocol design. Is very simplified. First, client establishes a connection to the server, and then the client sends an HTTP request, which is the request headers and body. And then the server will send an HTTP response with also its headers and body, well, status, headers, and body. And then the server closes the connection. In reality, for HTTP to work, you don't have to close technically, though you should. Otherwise, it won't really work. Like your pages won't load, and we'll show that. Also, the client or the server can close the connection. Though in this case, I think it's best that the server does in most cases. So let's live code some HTTP. I'm going to use, I'm checking my notes, make sure I didn't miss anything. I'm going to use a tool called NC. Does anyone know what NC is? Okay, you probably do or may have heard of it. It's basically a networking Swiss Army knife. You can connect to or listen on connections, UDP or TCP connections. It could do a lot. And I think modern Mac OS X operating systems don't have it installed anymore by default. So yeah, also be careful with NC. If you see somebody tell you to run an NC command, really know what it's doing first, because it could really mess you up. Basically, a lot of hackers and penetration testers use NC. So be careful. Okay. Let's create a listener. So I'm going to do listen on port 8080. And I'm going to just connect to myself, localhost, on port 8080. And then here I've created a socket connection, a network connection, and I can send any message I want. So this is the client sending to the server. The server can also send from server to client, right? So this is just TCP connection. No, there's no HTTP, there's no protocol here, right? Okay, so now let's speak HTTP. To do that, we have to send HTTP formatted text, HTTP 1.1. Cool. There. Server receives this. Once the server receives it, then the server has to return HTTP 1.1. So this is the standard 200 OK, or whatever your status message is. And then hello client, whatever your body is. So this is the actual response. Cool. That's it. Then I said the server closes it. So server will close this connection to the client. Done. Let's do that again. Let's do it with curl. You might know what curl is. If I curl localhost 8080, it sends this request and all the curl headers to this server. So let's see what curl says to my raw server here. It says get/HTTP. Okay. Let's do it again. Let's do a get on API hello. So you can see that curl will just send this information. And curl right now is waiting for a response from the server. The server has to send a properly formatted 200 OK hello. Cool. And then close commission. Right. So we just spoke HTTP. Oops. I'll start one more server and I'll not send HTTP. This is not HTTP formatted. Whatever. Okay. That's just raw information. So the whole point I wanted to get across here is that with traditional HTTP, which is super great for most cases, like asking for documents and receiving documents and images, it's powerful. It's really good. It scales well. And you have to close the connection. With WebSockets and server-sent events, what happens is it's still running over HTTP, except it doesn't close the connection. So it allows you to send messages back and forth longer for the same connection. Make sense? Oh, yeah, arrows. Okay. Yeah, so let's go a little bit deeper and we'll look at a raw socket in Node. Is my text big enough? It's big enough here.
Can you make it bigger?
All right, so first I'll create a server using the net module in Node, and then I'll use the create server command to create a server variable. I'm passing in client connected, so this is the handler. So I handle what happens when a client connects to this server, and handle errors here, right? So it's going to listen on port 8080. So on the left side here, this will be the server. So I'm going to node socket. And then let's curl localhost again. So what happened here? Node received a connection. So it said client connected. Client said this, which is the HTTP request. And then I wrote back, so client.write. So it sends back, I don't know how to HTTP. And then it closed the connection. And that's why my curl isn't hanging. So yeah, that's it. So a lot of this will kind of make sense in a similar pattern when we use server-sent events and WebSockets. Let's do another. The difference between not HTTP and HTTP is just writing the properly formatted HTTP headers. And yeah, I'm not going to run that. That's just reference. Let's see. Let's do bidirectional. So this, creating a new server, handling client connected. And in this case, I'm going to set an interval every 2 seconds. I'll just send some crap data. All right, let's run that. Cool. So again, this is it's keeping the socket open. It's writing to the open socket to my my original request here. Client write date.now. That's what's happening every 2 seconds. I can do that again. So same thing with NC, similar. I can also talk back. So this is the bidirectional communication I'm talking about. Server is sending this date timestamp, and the client is sending messages. Hello, hi. Cool. So we have bidirectional communication just with your basic net module in Node. So with this, we could create a server like, or sorry, a chat room like Slack. So if I did Node broadcast, very similar. Here, I'll have to store my clients. So that's important so that I can know which clients to broadcast to. Client on end, this is super important. Whenever a client disconnects, then it's our job to remove them from our clients array, because when I broadcast, I am going to broadcast to every client in our array. If that connection is not there anymore, this server will crash. So, so yeah, let's have a little bit more fun with this. All right, so on data, this is when the client, the connected client writes or sends message to our server. Then here we'll broadcast it. So for every client that I have, I'll filter and make sure that I'm targeting every client who's not me. So send to everyone else. And then for all of those clients, I'll just write to that socket with the data, the raw data from the client. So let's see that in action. I'm going to open up a few more. NC, do hello. All right, I'll connect to myself again. Hello. Hi, this is me. So you can see that they have 2 clients here. I have one up here, one down here. When I message from client 2, it's broadcasted to client 1, and I'm also logging it for development reasons on the server. So let's see if you guys can. Yeah, let's do this. This is port 8080. So let's do a TCP port 8080. I'm going to post this. I'm going to post this on the Slack. Can somebody do NC? Somebody do that. If you have NC program. If you don't, then you can use Telnet. And I think Telnet is also doesn't exist on the latest versions of OS X for security reasons. I see people connecting. Hello, can you see me? You just type and press enter. Oh, cool. What is your name? Yeah, so I created a very simple broadcast server using, again, just the net module and just iterating over some stored clients in an array and writing to the to every client whenever a client sends over a message. Whoa, whoa, that's interesting. Cool, so let's move on from that. I'm gonna kill this. All right, so what do you think we should do in a browser application if we wanted to update the UI with current info from the server and all we're using is HTTP? What would you do to solve that problem? And this is a very common problem, like stock updates or you got mail. How would you solve that problem? Without WebSockets.
I'd use a polling, some sort of polling function.
Anyone?
I agree with Sean. Like a polling function.
Polling, yeah. Like we have HTTP, we have fetch, we have Ajax. I don't know if anyone calls it that anymore. And we could just poll and update the UI. And that'll work most of the time. It's also very simple because we're using the tools that we already have at our disposal. So polling. Polling is basically while true, do curl or fetch the URL and then sleep and then do it again. So over and over and over every 5 seconds or every 1 second, however often you want to poll, which could put a lot of stress on a server if you have a lot of users and you have a low polling interval, right? Still not too bad because it is HTTP and HTTP scales very well. So yeah, easy to handle. So let's go through that demo real quick. We're going to build a little application. Oh. All right, wait, am I still running? Nope, everything's dead. Okay. All right, I have a little application here to demonstrate polling. Here's our React application. It's just a bare, everyone understands this, right? Import React, let's render, create a, it's not legal because I need to return some JSX and then render the application into a container. Just to show you, nothing's fancy is happening here. I'm just importing the app.js here into a container or rendering it into the container. And then I have an API too. So again, nothing fancy here, just Express API, app use API. I have some, yeah, I have my API here. Cool. So I think we're set. Let's start building. So in my front-end app, React, most people understand React. I'm going to define a poll interval. So I'll set it to 2000. So 2000 milliseconds should be 2 seconds. So every 2 seconds, we'll get the latest updates from the server. I'm going to create a new component to hold an activity log. So what we're building is a real-time game event viewer, right? So I have some props. You don't have to worry about that. Basically, they're a bunch of LIs with some formatting. Cool. All right, so down into the main application, I'm going to use state. So I went to the React hooks talk a couple weeks ago, and I learned how to use hooks. So we're supposed to create set logs, and we get logs from use state. We have to put in a default state. I'll use an empty array. And then I'm going to use ref, which I haven't really used much before, to set my timeout. I'll show you what that does when we use effect, which is like component did mount, or that's how I'm using it. So here it is, timeout.current, which is a use ref thing, setting the current value of that ref to, I think I want set interval. Yeah, or set timeout. Yeah, set timeout every 2,000 milliseconds. Here's my set timeout callback function. This will run every interval. In it, I'm going to fetch, and from my API, I want something called game events. So I'll create that after I do the UI. And then, with fetch, you want to, I know it's going to be JSON because I'm going to write that. And then I'll set logs. So I'll run set logs with the value of this response, right? So I expect this to be an array, which will replace what the logs are. That's how hooks work. And then my poll interval. Cool? Pretty simple so far. You can stop me if something doesn't make sense yet. Though right now we're just building a HTTP poller using fetch. Dependency for this use effect is logs. Whenever logs renders, we do this again. Yeah. So I'll return my app, my DOM, the UL that contains the LIs. I call it event logs. I'll map over my logs, which is an array. It's empty for now. For every log, I'll use my activity log component, pass in all the props. So the key, source player, target player, type, and weapon. I think that's good. All right, save that. We'll go to the API. All right, so this is I need a router to mount. I'll export that router. I'm going to get some game data. Agents and weapons is all I need for now. So here I'll create a endpoint called game events. This will be mounted on API, so it'll say API and then game events, right? So here's the handler. Oh, I need to make a data source. So this is going to be the response that I send back when somebody requests game events. So I'll simulate the data here. I'll respond with the data source, so the array, which again is simulating it's a collection of records from a database or some other data source. So I need to create some or simulate some actual events. So I'm going to create a function called queueGameEvent, and here's the function body. It's going to set timeout, and oh, I don't want more than 3 events in here. So if it gets to be greater than 3 events or equal to 3 events, then just remove it, remove everything in it. I'm going to add a new game event. I know this doesn't make a lot of sense now, though. Basically, I'm just setting up an API for simulation, right? So game events, next value, I'm going to create a generator function called game events. And then what it returns, I'll push into event data source, right? So, and then at the end of this timeout, after pushing to my data source, I'm going to call the same function again, queueGameEvent. And then I want the set timeout to be random, random to 2,000 milliseconds. So somewhere between 0 and 2,000 milliseconds. Actually, I don't want it really to be 0, so I'm going to make a minimum of 200 milliseconds. So somewhere between 200 and 2,200 milliseconds, we will queue up a new game event. So here I'll kick off the recursive function. I'll make the generator. So it's called game events, generator function. I invoke the generator function, so it returns me the generator. While true, it's how generators work. I make some random data, simulate actual game events. And then I yield the result, which is a object with ID, type, source player, target player, weapon. All right, so you kind of get what's happening. Cool, so I have my API set up. And main thing is whenever I request game events, I get this. So let me run. If I hit API, game events, I should get an array. Cool, I have an array. So let's run that in a browser. All right. Let's inspect what's going on. Wait, how do I? Wait. Oh, there it is. Okay. So as you'd expect, based on the quick live code, every 2 seconds, the front end is requesting game events and getting all of the game events back from the server. That's your basic HTTP polling. So I did this pretty quickly to demonstrate why it's not great. Is anybody familiar with this logo or this graphics? Yeah, it's a game called Valorant, and it's a multiplayer game where, and this is to simulate, you know, actual Sage kills Breach with this squirt gun. I don't know that it's very valuable for me to see something that could be 2 seconds old by doing HTTP polling. So yeah, I'm kind of seeing the latest greatest, though it's not like it doesn't make sense for this application where I'm delayed by up to 2 seconds. Or I could lower the interval, though, you know, it's not near real time. And so we're going to fix that with WebSockets. Let me see if I have anything else in my presentation. Yeah, let's live code some WebSockets. Anyone have questions on HTTP polling so far? Like, look at all these requests. Imagine that times 100 users and a faster interval. And another big thing about this is I'm sending over all the data set. Like, if I put, where's my purge? Here, let me just not purge events. So now what the UI is getting, and this is totally a use case I've seen in the real world, is I'm getting all of the events every time. That's not very optimal, right? So in this request, I've gotten the same data that I've had since the previous request. So here, previous request has 14 elements. The next one has 16 elements. I didn't have to get all of the other old data that I already have. So WebSockets will definitely help with that. I think I talked about all the benefits there. Yeah, all right, let's move on. No one has questions. Let's do this same application in WebSockets. So let's go to the front end. I'd like to start at the front end. All right, so this is some of the same React code that we just went over. Activity log is the same. Render, event logs, list. All right. And so this portion should show how to set up the client with WebSocket connection to the server. And then I'll go over the server accepting WebSocket connections. So first I have to use state. So I'll store logs in state. I'll create a socket variable or ref and start it at null first. And this is some React hooks magic that I don't fully understand. It took some time. It's though the main parts is that we're creating a new WebSocket instance or connection and storing it onto this ref. So for this WebSocket, I need the URL. And if you've never used WebSockets before, this will be really useful for you. Do this first. Find out what your protocol is. So protocol being HTTP or HTTPS will give you WS or WSS. So if in a browser, if I use window.location.protocol, then I know that I'm using HTTP. So I should use WS as a WebSocket protocol. If I'm using HTTPS, I need WSS as a protocol. So that's what this ternary will do. So based on a window location protocol, if it's HTTPS, then I want WSS is the secure equivalent of WebSocket protocol. Otherwise, I want just the insecure WS protocol. Then to build the URL, you need a full URL. You cannot be like a relative path. So I'll build out the protocol. So WS : slash, and then the host name, which would be localhost, the port. So the port in my case is 3000. All right, so here we pass the WebSocket server URL to the new WebSocket constructor, WSS URL. And then for a cleanup step and this React hook, or this use effect, you return a function, and I want to close the current socket connection if this component unmounts. So that's what this cleanup step is for. So I'm going to do another use effect. And this is to update the logs based on when I get new messages from the socket. So first I'll make sure that I have a socket connection, because at first it's null. See up here, null. So if it's set, then continue, else return. So don't do anything if I don't have an open socket. I'll take that open socket, I'll add a new event handler called onMessage, and pass it a new function. So every time this use effect, or every time this component renders, it will create a new onMessage handler. I'm going to parse the message. So e.data is going to be the message, and I'll call it game event. So now I can set logs and pass in the previous logs, and then concatenate or append the new game event. So I'm basically just appending to the array of logs, right? So this is the magic that happens whenever I get a message from the server, then update the logs. I think I need a dependency here, so yeah, logs. Whenever logs changes, rerun this effect. Oh, yeah, let's run this. Let's go over to the API side. So this is, like I showed earlier in the basic Express example, this is how a basic Express server is set up. To hook up WebSockets, it's not too hard. You can look it up. There's a lot of examples, and I'll do it step by step. First, we have to use HTTP create server. So we require HTTP, and we pass in the Express app to it as a server to serve. Now we have server here. We'll use that later. I need to get a WebSocket server. So we require WS, and this is not a node module. It's part of the standard library. So require web server, call it WebSocket server. We'll construct that soon. I'll make an instance of WebSocket server called WSS, new WebSocket server. And here I'm passing in server : server, right? The server that we created here. That's how you wire it up. And then I put my handler in a different file. It's kind of good pattern to do. So I have my WebSocket handler in this file here. And then I'm going to do a WSS on connection. So that's whenever the WebSocket server instance has a new connection, then pass it over to the WebSocket handler, this whatever this exports. Finally, instead of using app.listen like all the other examples show, like app express.listen, we're going to use this server, which has this WebSocket server attached to it. So server, it's going to be server.listen instead of app.listen. And that's your basic wiring up the WebSocket server. So basically these lines, your handler, and then just listen. Okay, almost there. So with the WebSocket handler, I'm going to bring in some game data to serve to the client. We need to store clients, connected clients to an array. So here's our clients, much like the broadcast example we did earlier. So that's where the similarities lie. We need to export the handler itself, and then let's create the handler. It takes a client, so the connected client. So this function runs when a client connects. All right, so first thing we want to do is add a client to the list of clients. So like I said, this happens when a new client connects. So as soon as this client connects, let's add him to this array. So we push to the clients, this client, right? Clients array. All right, now we're tracking him or her. Handle incoming message from client. So now we want to handle the message that comes in from the client. So if the client says something, what do we do? In our callback function, we have a message as an argument. And let's just console log it so we can see what he's saying or she's saying. And finally, we definitely want to handle removing the client from the client list, like I mentioned earlier. So we'll use client on close, which is part of the WebSockets API. Here's our handler, and we'll say client disconnected, so we can see that happen. We'll mutate the array in place, so we'll use splice. We'll get the index of the client that has disconnected. And then 1 here to how many we want to delete. So we'll delete this client from the array. All right, so that happens. We'll handle errors. This is good to do, especially during development, or all the time, actually. So client on error. So if there's an error that happens for any reason, let's at least look at it, and then we'll handle it better once we know what's going on. All right, so the rest of this is going to be similar to the HTTP polling example. So I'm going to breeze through game event, set timeout, broadcast new game event. Okay, so here's the difference. Every time a simulated game event happens, this is how we broadcast to the new game event to all clients. Very similar to the broadcast, raw broadcast example we did earlier. So for every client we have, we do client.send, and that's a WebSocket function. And then we're gonna send a stringified JSON object with game events next value, which is gonna be an object, a game event object. So I'm gonna write, oh yeah, I'll kick that off. And here's our random interval. And then here's our generator. So game events, generator, same stuff as last time. All right, that wasn't too bad. Let's run this. Cool, looks to be working, kinda. Right, is that right? I don't know. Oh, I know what I did. All right, so I'm getting all of the events. So I'm gonna go back to the front end, and so here I'm setting logs to every log, which is not too bad because if you debug with the WS console here, see messages, it's only giving me what's changed, the last event as it happens. So it's not sending me back, 1,000 old events. It's only giving me the latest. So that's okay. Though I don't want it to, that's not how the Valorant game UI looks. So I'm gonna do a max of 3. So I'll purge old events. So if logs length is greater than 3, I'll only append to at most 4 or 3 or 4. Cool. So now it's purging old events. All right. We can see here that as the event happens, it's broadcasted to every connected player. And then, yep. Cool. So I just hooked up the client and the server using WebSockets. Any questions here before we move on to server-sent events? All right. Yeah, I definitely like this real-time update. Better than polling. A lot less data is going over the wire. That's good. I always like that. And one thing you'll notice is that I'm only getting messages from the server. I'm not sending any messages back. So this is where server-sent events come in. Wait, did I have anything else? Oh yeah, debugging WebSockets. Let's go there before I move on. It's kind of it. I kind of use this the most. So to do that, in your Chrome inspector or Firefox developer tools, filter on WS, find your WebSocket. You can see the headers. It does a 101 upgrade, HTTP upgrade, and then your messages. This shows timing and your actual data. Super useful for debugging your game or application. I think I wanted to, yeah, no, I don't want to talk about that. All right, okay, fine, let's talk about this. Let's do, all right, so I'm gonna log into Slack real quick and we're gonna see, oh, I don't want that, I wanna actually go, yeah. We're gonna look at their WebSocket connections and just inspect what they do. I think I need to talk to somebody. I could talk to myself, wait. Talk to Hidani. Okay. I don't know if anyone has ever done this before. That's pretty neat to see what's going on under the hood. What is Slack tracking about us? All right, so I'm looking at WebSockets. Let's make this bigger. Here's our messages. Type hello. Hey, that's cool. Type presence. Type flannel. Presence change. Ping pong. So you'll notice that they have some kind of checking if you're alive or a health check. Users typing. Whoa. So it shows that the user is typing. This is the user code. And then users typing in this channel. And then if I type, it sends typing. So I'm typing. So now it's sending that I'm typing to that channel. So Justin Hidani must see that it, like on his user interface that I'm typing. Now, what's interesting is if I post something, or sorry, send a message, look at the message that happens. So I receive that, like kind of a receipt that I've sent a message. But this is from the server. It doesn't show me sending it. And the reason why is the way Slack wanted to implement their chat is through XHR. So, so when I sent a message, it actually does a post. So where is this post? I'm gonna just clear this and then do it again. Hi. All right, so chat, post, message. Here's the, here's what I sent. Message, I sent hi, and then I get a response. So that's pretty interesting that even though they have WebSockets and they could have sent this message over this WebSocket, what they do instead is when you post a message, it does a HTTP post request, which again, opens a connection, then closes that connection to this URL here. I have some ideas of why, though I don't work at Slack, so I'm not gonna make up ideas of why they do this. I do use this same technique, and I'll show you that. So if you're ever interested, see how the Slack does it, you can debug their WebSockets.
Hey, John.
Yo.
I had a quick question. So is it possible that it's getting sent there and then they encrypt it before they send it out? Or like, where does the encryption happen on Slack side?
I believe the encryption happens because all the information is sent over HTTPS. So it gets encrypted before any data is sent. It creates an encrypted tunnel. It sends all that data through TLS, and then yeah. So with WebSockets, it can also encrypt as well. So they're not skipping WebSockets because of encryption reasons. Actually, if I open that up again, the WebSocket path will show WSS. All right. So if I click here, that's a good call out. So if I click here, so request URL is WSS, which means it's encrypted over TLS. So yeah, that's where the encryption happens. Good question. All right. I want to talk about caveats. So there's a lot of extra work that needs to happen when you're implementing WebSockets, when your application is running over more than one process. So so most of us know that Node is a single-threaded process. So it uses one core when it's running. And if you wanted to utilize more cores in the server that you're running it on, let's say you have a 8-core server, which is very common, then you would do something called clustering. And clustering says take this application and run it 8 times on different cores, which is to utilize more of your CPU power. That's a good idea. Except when you're broadcasting messages, not that API. When you're broadcasting messages, this client's array is going to be different per process, as you can imagine. So if there's 8 processes and 100 people connected, if I send a message out, it's going to be broadcasted to some of the users, not everyone. So there's a lot of scaling work that you'll need to do to enable more messaging between processes. And yeah, not going to go into that now. It's not impossible. It's just a little bit more something you have to think about, because I've been in situations where we've used WebSockets and we had a short deadline, and then they're like, all right, now we're going to production, and it's deployed onto an 8-core server, and we have 8 processes. So things went really wrong really fast. The obvious solution was to scale down to 1 process until we implemented some messaging bus in the backend. What else? I think that's kind of all. We could talk more about drawbacks of WebSockets later. Let's move on. We're more than halfway through. So server-sent events. Let's do that. We're going to do the same exact thing we just did, except in a different fashion. So server-sent events, I'll show you how that works. I'll start at the front end first. Again, here's our React application, same activity log, same top-level component called app. For every log, we'll render an activity log. We'll use state and logs. So here's where the differences come in between polling and WebSockets. And if you remember, I talked about server-sent events is one way. So we'll only be getting updates from the server, which in this case is perfect. All right, so we have a variable called events to hold our ref. We'll do our use effect like we did last time. So with events, we'll have to use current, and we'll create a new event source. So it's different than WebSocket, obviously. So it's called event source, and we pass in the path to the API endpoint. So I'll have an API endpoint called the game events, just like we did with polling. And same as what we did with WebSockets, we also want to clean up when this component unmounts, then we want to close the connection. So here's the callback function. We'll say events current, that's the ref, and then we'll close the connection. We'll do our second use effect to update the logs. Make sure that we have our event source set up before we run. And then we have an on message. So for this event source, on message will handle a message that's coming from the server. So this is the event. Here's our body. We'll do the same thing we did with WebSockets. We'll parse the message as JSON and call it game event, and then we'll update our logs. Cool. Very similar, except we just have this event source, and then we could use a relative path. We don't have to have that, look for what protocol I'm on. This will already know what protocol and host I'm on, which is kind of nice. All right, let's run over to the API real quick. So here is our API. Wait, do I want API? Yeah. Yeah. All right, I'll start down here, I guess, with the Q game event. Whenever there's a new event, we want to broadcast that to all our clients that are connected. The differences here is that instead of just passing whatever data we want, we have to put this string data, data and then our message. So again, instead of like with WebSockets or even with HTTP polling, I can put, you know, hello, and then world as a valid, you know, JSON response. That works for, you know, fetch and with WebSockets because I can expect that to happen. With server-sent events, the difference is we send data colon and then your message here, right? So that's what this is, data something. And then we need 2 new lines afterwards. That separates this message from the previous. So those are the differences between server-sent events and WebSockets. Okay. All right, so everything else here is the same. Everything here is the same. Just hide this. All right, and then we'll hook up our game events API. It's going to be different than the polling, though it's hooked up the same way. So we're using our same old API. We're doing a get on API game events, right? And again, I have my clients array connected. Here we have to send over special headers. So as a response header, we send over text event streams. That's new. We also want our connection to keep alive and then no cache. We immediately write this header. So status code 200 and these headers. That's kind of it. That's all we want to do here, except we also want to, you know, store the client. So in this case, the res object from this API endpoint handler becomes our client. So we push that to clients. And just like last time, we have to make sure that if ever the client, in this case, we'll call it rec, or in this case, we reference it as rec. So rec.onClose, when this request closes, we can say client disconnected, then we remove the client from our client's array like last time. Otherwise, we'll be broadcasting to a closed connection and that will crash the server. If you wanted to, you could send a first update. So, oops. So at this point, when someone connects, you could say, hello, connected true, and then end. Actually, you probably have to do data, right? Okay. Cool, that's it. That's how we hook up our API. Again, this is our handler. All this is on GitHub. I can share that with everyone at the end. And then we write with this data and new line, new line. And let's see how this looks and how we debug this. Oh, I have the same issue here, so I'm going to solve it. I want to only keep, where is it? Where's my logs? Here. I don't want all the logs. I just want to show the last 3. So purge everything older than 3. All right. Cool. So let's debug this. If you look in WebSockets, I don't have a WebSocket connection because it's not a WebSocket connection. It is an XHR connection, just like polling, except instead of showing game events every 2 seconds, like 100 times, if I click here, it'll show thing called event stream. So this event stream is just pushing the last event to my UI. And I'm storing it in the logs state array. Very similar to WebSockets, except I'm only receiving, I'm not pushing, which is fine because I don't need to push. Yeah, so this is an open connection right now, game events. Let's do a little bit of debugging. What if I curled localhost 3000 API game events? Cool, you can really see what's happening at a more raw level. Remember I told you it needs data colon, so there is that. After that is the string of the data. And then it knows when it's done because of these 2 new line characters. Then this becomes a different message, event message. So when I did Control-C on my curl, it showed client disconnected, and so it's no longer sending me updates on that closed connection. So that's that cleanup step. I think this is a lot simpler and easier to implement, really. Yeah, and it's really just, it's very close to HTTP in that if you've ever set up a reverse proxy like Nginx in front of your node application, and then someone implements WebSockets, for example, and their WebSockets aren't working, it might be a misconfiguration issue because they have to do extra things on their reverse proxy, and that can happen many proxies deep. If you're behind a load balancer and several other layers, you have to make sure that WebSockets are supported. In this case, with server-sent events, it's just HTTP that's pushing more, that doesn't close the connection, and it's pushing more data to the client. So you don't have to do anything special on Nginx or reverse proxies, since if it handles HTTP, it'll handle this. Cool. All right, let's have a little bit of fun. I don't want to spend too much time live coding. Let me make sure I got everything here. Debug. So debugging server-sent events is very much like HTTP, except it's really cool that now we get, I remember doing this when we didn't have this event stream panel. So this is a new addition to Chrome, Firefox, pretty cool. So yeah, I use curl. I use curl a lot to look at my event stream. If I'm missing something, that's why it's not working. Caveats for, yeah, so server-sent events, maybe we don't see much of it because how's the support on it? WebSockets has been out for a really long time. The spec has been out, stable browsers support it. Well, let's see what the support is here. No Internet Explorer. So if you use Internet Explorer, you cannot use an event source. So stick to WebSockets. Maybe that's why we don't see it, because people like to use Internet Explorer for some reason. So that's important to know. All right. I'm going to do before we get into this, I want to do a little bit of fun and modify, so right now we're doing only server sending over to each client, broadcasting events to every client near real time. What if we wanted to have the client send back data to the server and have that broadcasted to everyone? So I'll do a quick simulation of that. I won't take up too much time doing this. So a lot of the code is the same. I'm just going to show you what's different. Okay, so let's start with the WebSocket. Let me kill this real quick. With the WebSocket example, I want to make it so if I click on an event, then it tells the server that I like this event. Like, yeah, Raise, oh, Jet killed Raise, like. You know, that's what I want to do, okay? So I set up some DOM stuff, some stuff for likes, not really important. I'm going to set up the on-click handler. So when you click on something, it is handled. So on click, I'll make a function called click like, which is the handler. So click like. So I'm going to use the open. So again, this is WebSockets, right? So I'm back to the WebSockets example. So I'm going to use the current WebSocket connection, and I'm going to send a new message. So that's all it takes for the client to send over a message to the server. You just say socket send, and then whatever you want. In this case, I want to send JSON. So this is normally what I would send, right? The ID, the X and Y of where I clicked. However, the new pattern that I want to talk about with the op and payload, which is very similar to what we saw with Slack, and they used type. So it's a type. They always had a type. That's really good to have. So instead of having unstructured JSON, you should have some structure. And I like having op as a mandatory key in this payload or in this message, and then what I'm doing. So what is this operation? I'm sending a like to the server, and then another mandatory key, which is payload. Everything else that's related specifically to liking will be in payload, right? So now I can expect every message sending back and forth between the client and the server will have op and payload. Cool. That's it. That's how you send from the client to the server. Now let's look at the WebSocket server side. I think it's WSS. So I need to handle this message coming from the client. So I will pull out op and payload from the message. So I'll parse out the message that comes, that's received. And then I have op and payload. I know I have that because every message will have that, which is a really nice benefit. Then I could do a switch on op, makes organization very simple. And then I know I'll have like, because I just built it. And then before I even implement anything, I'm going to set a default case so I can develop really quickly and tell myself when I've forgotten to handle a operation. So default, I'll warn myself that I received an unsupported op of this. Then I could go ahead and implement it right away. Okay, so now I'll do handle like client. So now I can abstract this logic over to a new function. I'll send over the client. I also want to send over the message that actually I don't want to send a message. I want to send the payload that the client sent. So handle like, client, and payload. All right, let's make this handler, handle like, client, message. I'll pull out ID XY from message. This is specific to the op like. Only op like has this payload. Also, if you use TypeScript, this will be so much easier for you. You can type your messages. So here, I want to broadcast a heart to all connected clients. So let's do that. Clients for each. I'll send over op again, always sending over something like, and then the payload. So I'm just broadcasting the same message. You don't have to do that, sorry. In fact, I should have filtered. So since I have client, I could do a dot filter client. That client is, or C is not client. C client is not. Cool. Now I'm sending to everyone except for myself. Oh wait, maybe I don't want to do that. Maybe I want to only animate. Yeah, I want to send it to myself too. Okay, cool, cool. All right, let's run this. What? Wait, what? Where? Yeah, I don't know what happened. Oh. Okay. All right, I'm getting my game events, and when I click, then I'm sending likes over to the server. All right. Yeah, let's play with this a little bit. I'm going to send over this URL, and I want to see if you can like some of these events. All right, so if it's working correctly, if I did my job, then I should be able to see. Oh, someone really likes Sova. Okay. All right, raise. Cool. So as you guys are spamming Viper and Brimstone, I can see the server sending me these likes, and my UI can update and render these hearts. Pretty cool. So that's how it works in WebSocket world. Basically, send your message over the same socket. Very useful. All right. Oh, cool. So I'm also seeing my server logs are spamming. That's nice. Okay, I'm gonna kill this connection so we can move on to the last demo. Though, remember how this feels to click though. This is WebSockets, so you can see how it feels to send WebSockets over to be broadcasted to everyone else. It feels really good because we're gonna do this again with server-sent events, and it's not gonna feel this good. So notice how this feels, this responsiveness. Okay, killing. Okay, let's go server-sent events. How would we do this if server-sent events is not bidirectional? It's unidirectional. What do we do? Oh, let's see who's paying attention. All right, server-sent events. I want to send over likes the same way. What would you do if you don't want to rip out server-sent events and put in WebSockets? How would you send over likes to the server? One vote for post, HTTP XHR request, posting some data to the server. Anyone else have ideas? Any plus ones on that idea? No response.
I mean,
I guess we're gonna use HTTP post. You win with one vote. There we go, 2 votes. All right, so let's go over to server-sent events. Client side, we'll start the same way with our click like handler. Here's the click handler when you click on a activity log. We'll use fetch, so XHR request to API like. So we'll create a new endpoint called like. And then we'll make a post request, send over it as JSON. For the body, we're gonna stringify an object. And I think, yeah, I'm not using the op because op makes sense to me with WebSockets, so I can do a switch on it. In this case, it's just the endpoint. It's not a real-time update thing, so I'm not using op in this case. Because basically, if I want to do a different operation, I'm going to fetch it. I'm going to post to a different endpoint, right? It'll be like API dislike or API kick or API logout, right? So that's how I'll switch between operations. In this case, for API like, all I'm going to be expecting is this payload. So I'm not using op pattern here. Yeah, I don't need that. Okay, so that's it. So when you click on something, we'll fetch, do a post to the server. On the server, we need to create, so just familiarizing yourself with this. This is the API with the get game events, with the server-sent event headers. All right, so here I'm going to create a new post route. So API post, I said it was /API/like, so like. So our handler arguments. I'm going to do a little bit of error handling. I should be doing more. So I expect ID, X, and Y to be in the payload. So every one of those parameters should exist in rec.body. Otherwise, return an error because I need those. Otherwise, I don't want to broadcast it. So required parameters are ID, X, and Y. I'll pull out ID, X, and Y from rec.body since I know it's there because we just validated a little bit from rec.body. Here we'll broadcast likes to all connected clients. So clients for each. We'll write, so it's client.write instead of client.send. And being a server-sent event, you need to have data. And then here's our op like. So I am using ops now because for this server-sent event stream, I'm expecting game event or like. So since it's an open connection and it could be any kind of message, I'm using op as my type for how to handle it. So op is like, and then send the same payload over, and then the 2 new lines that server-sent events need. So what is this? Oh, and then, so because it's a post, you have to close the connection or send something. You could send empty response, or you could send a success true. That's fine. So I'm sending success true. It really doesn't matter. I'm not handling it in any way. It really matter if I send an error like this. So res JSON error. Cool. Yeah. So that's how I'm doing it. Again, when someone posts to like, I iterate over every client in my connected clients array. And then, and I send them all that piece of data. In real applications, obviously, there'll be a lot more logic. I wanted to keep this as concise as possible. Basically, you just write to that open res. So clients here is like saying res.write because we pushed that res here, remember, as a client. So that's why that works. Let's run it. Okay, all right, so I got my event stream. And here I'm sending these likes here. See his like? So for every like I do with server-sent events, it does a new post request. Again, opening a connection and sending the data, closing the connection after we're getting a response. Let's have fun again. I want you to see how it feels to spam likes on a server-sent event using HTTP post. So I posted a link to Zoom group chat. If you want to click on that, and love Cypher, yeah, love Cypher, love Jet, love Phoenix, yeah. So yeah, I don't know about you, mine is feeling a little bit sluggish. So what's happening is it does the it does the post request, then it broadcasts to every client, including yourself. And when yourself gets it from the game event stream, see here. So when I click and I get my like back, that's when I render it. So I only render it when it has been registered and everyone else has seen it too. Right? So that's why it feels a little bit sluggish. It does a full round trip of opening a TCP connection, setting up for HTTP, headers, body, parsing it all, and then closing it up again. So I don't know. This is how you would do it. And even in this use case, I think server-sent events are fine. Who cares about trolling people who want to spam these hearts? My server can handle it. Actually, servers can handle HTTP requests probably nicer than a whole bunch of WebSocket connections. So for this project, I think I would choose server-sent events and go ahead and post a bunch of likes because it feels performant enough to me. It is near real-time updates. I'm getting that. That's the main thing I care about. And it could scale more. It could definitely scale more. I can, remember I told you with WebSockets, you'd have to do a lot of, well, no, in server-sent events, if you're broadcasting to every user, then you have the same scaling problem there. However, if you're just broadcasting one-way information like this, game events, then you can run, across 8 different processes without having to do any extra work. Actually, it'll just work because your data source will be updating your API. The API will be pushing updates to every connected client, and every connected client in this case wouldn't have to see everyone else. When you do something like this, that I'm broadcasting these likes, yeah, you're gonna have to have some messaging between all of your processes. Yep. Okay, let's finish up here. Oh yeah, this is funner part. So yeah, that was the op payloads I was talking about. The benefit to me is when I'm determining what to do with a message, when a message comes in, because all I get is on message, I could do a simple switch on the op, and then based on what that is, handle that, that logic. Based on what this is, handle that logic. It's real simple. Oh, yeah, we already went over this. I should have put that in the beginning. The messages in Dragons vs. Unicorns, if you remember, had the same op payload pattern as this. Abstractions and alternatives to WebSockets. So if you've noticed, I haven't really NPM installed any, socket.io, or I don't even know if socket.io is that still a thing? Do people use that? I mean, on purpose, not because, legacy. Anyone know? Socket.io was a very popular WebSocket, abstraction to make it easier. Well, I think just WebSockets alone is pretty easy. As I've demonstrated, it's not that much more work than using something like Socket.io to use WebSockets. Yeah, let's look at some alternatives. For the second game that I showed in the beginning, or the hacking simulation, I experimented with a new abstraction over WebSockets. It's called Calicious. Calicious.io. It's a multiplayer game server for Node.js, focused on gameplay. So what intrigued me about this and made me want to learn it just for that one instance is instead of having to, manage all of your messages, like I want to send a like, or I want to send a message to this one player in this one room of a chat room or something. That's a lot of you have to keep in your mind and write your own abstractions for to keep that organized, which is possible. It's very possible, though it could get pretty hairy, maybe. It's a little bit easier to handle with my op pattern. Anyway, the difference with Calicious is you define schemas, and then Calicious will use WebSockets to keep all connected users in sync with with the game state on the server. So you define a game state on the server. If that state changes for any reason, then it just updates all of the other clients that are connected. I'll show you real quick how that looks. So there's an idea of schema. If you use this, definitely use TypeScript. So if I say, okay, the world has a width, height, and items, then if ever width changes, then everyone sees that change automatically. That's pretty nice. The items inside of this, oh yeah, items number changes. It also handles maps and arrays pretty well. So if items in an array changes, it'll reactively update all clients. So that's pretty cool. What else? There's PubSub. So that's publish, subscribe pattern. Let's look at that. PubSub. I don't have any examples for this. Just know that it's another way to organize real-time updates. You can subscribe to a topic, and then the server can publish messages to individual topics, which you can think of like rooms in Slack. You only want to dispatch messages and events to certain people who care about that. Maybe they're on different screen in Spotify or something. Protobufs. So this is not an alternative to WebSockets or server-sent events or HTTP polling. This is an alternative for the format or for the data that's being sent over the wire. So let's look at protobufs real quick. Protobufs. So there are protocol buffers. We call it protobufs. You define a schema. So a person has a name, ID, and email. And then this is called a PB file. Oh man, someone might have to help me remember. Though basically you define a PB file, and then it compiles out to whatever runtime you're using. So Java, Go, C#, Python, JavaScript. It'll take this and then output a JavaScript file, for example, of this data format. And then when you build a piece of data, then you can send that over the wire, and it's very, very compressed. And the serialization and deserialization of what goes over the wire and what you define in this protobuf document is way faster. I believe it's faster than JSON, and it's incredibly faster than most things. So again, serialization, deserialization is very, very fast. Sending over the wire is very compressed. So it's really good for if you have lots of data or a high frequency of data. So I've used this before. I've used it in production, and I can attest to how awesome it is. Typically, when people use protobufs, they're probably using it with gRPC. And so I used it between server-to-server communication using gRPC, sending protobuf encoded data over gRPC. Unfortunately, gRPC is not well supported from browser client to server yet. I mean, I've done it. It's possible. It's not pretty. So we still have ways to go. Take off protobufs for your data encoding needs. Basically, codes it to binary and makes it really fast. Yeah, cool. So does anyone else have ideas of real-time or near real-time communication between clients or clients and servers? Have you run into any issues with WebSockets? Let's talk. Your turn to talk.
Which of those, if any, would you use if you were building a secure elections app of some sort?
Sorry, I didn't catch all of that. Was that a question or a comment?
As a question, like if you had to choose from all of those, I guess which would be best suited for building something like an election app, as an example?
Right. Election app, I would use HTTP and just send like HTTP requests and responses. Yeah, I think if I don't really know the scope of that though. For sending in votes, definitely just HTTP plain. It's very powerful. Everyone should be using that if possible. And when it's not possible because you need near real-time updates, then the choices are between WebSockets and Server-Sent Events or raw sockets. So I showed in this presentation, I wanted to show that, at least in my opinion, if you're doing a real-time game, like two-player or multiplayer game, then WebSockets are the way to go because you want to just use the same connection and send and receive messages as fast as possible. When you just need to push a bunch of updates in near real time to your clients and not need any interaction from them really, then consider using Server-Sent Events if your clients aren't using Internet Explorer. Lars, did you have a question?
Me, no, I'm kind of taking all this in. I'm kind of new to all this, so I'm just waiting to hear what other people have to say.
Yeah, Annie.
Hey, so you mentioned protobufs. So is it possible to do real-time communication with protobufs?
Yeah, so basically, I kind of like want a side project to take this Calisius project because I like its fundamental idea and it's pretty simple. And then instead of sending over, they serialize their own schemas in an okay way. I've seen it. It's still readable. I would want to make a branch or a fork of this and then use protobufs to send information way faster and to deserialize information way faster than what they're doing now. Yeah, it's just data. Like instead of sending JSON or instead of sending a big binary chunk, you send a small binary chunk because both sides understand the same. They have to both have the same protobuf file. For example, I guess I have some other. That's right. Anyway, here's a protobuf file. I define a service. Oh, and here's the, wait, where's my message? So I have a message, put log request, log detail list, prefixes, keys list. Where's my actual logs? I guess this is my actual logs here. So key and data, right? So you would define a message and then it will turn the actual value, whatever data is in here, it'll truncate it into binary and then send it over the wire. And then the other server would have the same exact profile. They have to have the same profile in order to decode it back to meaningful data. So yeah, you definitely can. But you would use protobufs. See this part here where it says service, this is all gRPC. And I want to be able to use protobufs over WebSockets instead.
So when would you use protobufs?
When would I use protobufs?
Not use.
When would I not use protobufs? Sorry, I couldn't hear. Sorry, I really couldn't hear the question.
Oh,
There's a really bad echo.
yeah. I guess I'm just trying to figure out like the pros and cons between like using protobufs and not using it.
I haven't used it that much though. Maybe compatibility. I've used protobufs with JavaScript. It was kind of a pain. I've used it with Go and it was very easy. So maybe it's too young. Other than that, like I don't see why not. Oh, you know what it is? If you don't know what clients are connecting to you, then they have to have your profile, which you could just publish your profile and people can talk to your service. That's a benefit. So if they don't have your profile, they won't be able to connect with your service. And Justin Hedani, if you have anything to add to that, because I know you've been using it a lot too.
Sorry, I think a bunch of us are like typing in the chat, but yeah, basically going off what Luigi is saying, it's like you get increased complexity like when you have to set things up. So if you notice, you have to write this protobuf file, and then you have to generate the code for your specific client or server, and that takes some time to get set up. And by the time you do this, if you're just sending data, like let's say you're just using sending messages, and it's not, you don't need to have it scaled, you don't have a lot of users, like it's a lot more boilerplate code to get to production, right? So like John is saying, like HTTP is still like super valid for a lot of things, right? These other technologies are there to enable you to do like more like real-time things if you're trying to do it. Protobuf, like the main advantage to me is like if you need to be streaming, like kind of what John's doing from server to server, and you need to send over large amounts of data, right? Like we saw user like client interactions today over like on a website where we're clicking buttons and stuff like that. But when servers need to talk to each other, they need to send a lot more data. So like let's say you have like a pipeline, a data like a ETL pipeline, like extract, transform, and load. You're just taking in raw data, processing it, and then sending it out somewhere, like maybe to an S3 bucket. This would be good for distributing the work amongst machines. Like if you wanted to build it from scratch, you could have like 3 machines do something and then stream that over using protobuf over like gRPC or whatever. You can do it over WebSockets if you want. Send that data over, and then the next machine can process it. So you're looking at like, gigabytes or terabytes of data. But if you're doing just like kind of the basic stuff, real-time stuff, it's up to you if you want to have that binary over the wire. And maybe John can correct me if I'm wrong. I'm not sure if, yeah, never mind. Yeah, that's about it. Yeah, Luigi, do you want to jump in? I agree. I think the throughput, if you set protobuf like through streaming, it's something like 1 million messages per second. So it's pretty insane for sure. Like it's capable of handling a lot of stuff. But it's up to you if you want to spend the extra time to learn the platform, get the performance increase. Like WebSockets, still a great thing to use, and it's super easy to set up, right? John wrote some boilerplate code, and he's already created like a multiplayer game. So it's up to you how far you want to go with your performance optimization.
Awesome. Yeah, I think that was kind of it. Anything new on the horizon? Solved a similar problem? No, I honestly wish gRPC happened for server to client or server to browser. That would be, then I would just use that all the time.
What do you mean?
gRPC isn't super good on like browser to I don't think you could even do, it's not fully supported for browser to server.
gRPC, not protobuf.
Yeah, gRPC, yeah.
Can you talk a little bit about HTTP2 paradigms, like messaging paradigms? I haven't looked into that, but I think it's comparable to WebSockets, right? It uses like binary. I'm not too sure, but that would be my question: is are there messaging paradigms that you know of for HTTP2 stuff?
No, that's actually, yeah, super on the horizon. I haven't done anything myself, so I cannot speak to it. Though there's also like other protocols coming out besides Quick. I think there's an HTTP3 spec happening, and I don't know what their capabilities are as far as bi-directional real-time communication. Yeah, we just have to find out, and hopefully this year someone can do a talk on it. That'd be really interesting. Cool. Yeah, I guess one last thing I'll plug is next week. Check out the React talk if you can. I'm not going to post it on here. Someone posted, are there good resources to learn about WebSockets? I'll post some in Slack. I don't have any that I've used other than MDN. MDN.io, WebSocket server. I mean, it's okay. It's not the easiest to comprehend. No, it's gotten better. I know this has gotten better because I use it often. Yeah, I'll post whatever I can find, and if anyone else can, post on the CLJS Hackers Slack. Cool. Yeah. Hope everyone got something out of this, and I hope to see you next week.
Thank you very much for the talk.
Thanks, John.
Thank you, John.
Thanks, John.
Thank you, John.
Thanks. See ya.